Hi future doctors, welcome to the next class. In this class we will discuss the motion of charge in both electric and magnetic field. Motion of charge in combined electric and magnetic field. So already we discussed in electric charges and fields how the positive charge is going to be moving in the uniform electric field and how the negative charge is moving in the uniform electric field. So if electric field is going to be upwards, if you leave one positive charge here, so always positive charge moves in the direction of electric field. So electric force is going to act in the direction of electric field upwards. Correct? Now E bar is in which direction? Upwards, positive y-axis. Now force is also acting along positive y-axis. Therefore, if you want to write vector notation, so F bar is equal to Q E bar. This is along J cap. Force is also along J cap. If you leave negative charge here, negative charge will move in the opposite direction of electric field, isn't it? But presently we are taking positive charge. Now we are applying magnetic field. So how we are applying magnetic field means this charge should move with velocity, means resultant force is going to become zero. Resultant force is going to become zero means the force applied on this charge due to magnetic field should be in which direction? The resultant force should be zero means equivalent opposite force should act. Therefore, resultant magnetic force should act in which direction means this is electric force. Now, magnetic force should act equivalent opposite means downward direction, isn't it? Downward direction means along FBB bar should be along minus J cap. Okay, motion of charge in magnetic field already we discussed. So further, what is the formula? F. This is Fe. So FB bar is equal to Q into V bar cross B bar. Already one direction is going to be decided. That is nothing but minus J cap, isn't it? Next, positive charge, velocity and magnetic field. Magnetic field should be in which direction and velocity of this charge should be in which direction to get resultant force 0. Because whenever resultant force 0, it will be moving with constant velocity. So this constant velocity means without any deflection. This is already moving in a straight line path. It will be moving in the combination of both electric and magnetic field in such a way that resultant force is going to be 0 or velocity is constant. So where we are selecting such type of electric field and magnetic field, we are calling it as velocity selector. So in the name itself it is there. We are selecting some amount of electric and magnetic fields in such a way that it is going to be moving with constant velocity. Normally, if you want to write formula in the combination of both electric and magnetic fields, so this is Lorentz force we will write. Q into V bar cross B bar. Now here we are discussing about velocity selector. Later, how it is going to be moving, we will see. FB bar minus J cap, then Q is already positive. Then V bar and B bar, in which direction if you are taking, we are going to get minus J cap. Here J means here remaining I cap and K cap you should be getting, isn't it? So I cap cross K cap. So IJ, JK, KI. KI is J, but here IK wrote, therefore minus J got. Therefore, velocity is in which direction? Positive x-axis. Magnetic field is in which direction? Positive z-axis. Therefore, if you want to write as it is, so to get resultant force 0 on this, so this will be velocity. Magnetic field will be coming like this. This is along K cap. This is along I cap. Then velocity is in horizontal direction. At that time, what we said? Resultant force is 0. Magnetic field, magnetic force should be equal to electric force on the charge. What is the magnetic force? Here these three are perpendicular to each other. Already we discussed QVB. What is the electric force? QE. So therefore, QQ will be cancelled. V is equal to E by B. So in velocity selector, this positive charge is going to be moving with this much velocity. Let us assume you are applying both electric field, magnetic field in same direction. If you leave one positive charge here, then this positive charge will move or not means this will be moving in which direction means on this charge force is acting due to electric field. But if charge is at rest, force due to because velocity is 0. Whenever velocity is 0, so this charge will not move, force is going to be 0. Which force? Force due to magnetic field is 0. Therefore, this charge will be moving because of the electric field. If you leave here negative charge, again this charge will be moving because of electric field in opposite direction. Positive charge will move in the same direction. So like that, you are going to take directions of both electric and magnetic field according to this formula. This is the Lorentz force we will call. So this is the charge, force acting on the charge or motion of the charge in both combined electric and magnetic field they are going to say. Now we will see only motion of the charge in electric field. Already we discussed magnetic field. So already we discussed in magnetic field, if it is perpendicular means circular path. So parallel means resultant force is 0, straight line path. So other than 90 degrees means helix we discussed. Now motion of charge in uniform electric field. Now this uniform electric field, let us assume like this. Uniform electric field means its magnitude and direction is going to be in the same direction. So if you are taking electric field like this, here which charge is available? Always electric field direction is from positive to negative charge. Therefore, directions will be coming like this, isn't it? Now, this field is going to be applied, horizontal distance x. Now, a charge is going to be placed here, positive charge. If you place positive charge, always this positive charge moves in the direction of electric field, like this. So, this is the electric field E. Now, this positive charge is moving downwards. What is the force acting on the charge? F equal to QE. What is the acceleration of this charge in electric field? MA is equal to QE. A is equal to QE by M. Already this one we discussed in electric charges and fields. If it is at rest, it will be coming like this. But now I have projected this one, this charge with some initial velocity in horizontal direction. Like this. With initial velocity u, I have projected horizontally. So already we have discussed horizontal projection from the top of the tower. Same like that, this is also horizontal projection, but in the presence of electric field. So assume gravitational field is going to become 0. There is no gravitational field on this. Now acceleration for this charge will be provided due to electric field. How much acceleration it is provided? QE by M. Therefore, but positive charge always moves in the direction of electric field. But we have given some horizontal velocity. Therefore, this charge will be moving like this and it will be coming out of the electric field like this. This is the path followed by the charge if it is positive charge. If you have applied, means if you apply initial velocity in horizontal direction for negative charge, then it will be moving in opposite direction. If you have given neutron, then it will be moving in the straight line path. That one also they may ask in exam. Now, what is the horizontal distance? What is the vertical distance it is going to cover? How we are going to calculate all this? And how much angle it is going to be showing? Deflection. So, same like projectile motion we are going to take. If you want horizontal velocity or horizontal distance, Sx equal to uxt plus of ax t square. If you want horizontal final velocity, Vx equal to ux plus axt. So what is Sx, horizontal distance? X equal to what is Ux? Ux is going to be ut. What is Ax means? There is no horizontal acceleration because electric field applied vertically downwards. Therefore, horizontal acceleration is 0. X equal to ut. Same like that, Sy is equal to, if you want vertical distance, how much distance it is covering. So Sy is equal to uyt plus of ayt square. So y is equal to, what is uy in this case? Uy is 0, ux is u. Therefore, 0 plus of, what is acceleration in vertical direction means, so because of which acceleration it is going to be moving means qe by m. Therefore, qe by m into t square. So again, what is the path followed by this means y is equal to of qe by m. So what is t can be replaced from here? T is equal to x by u. Therefore, if you write that x by u here, x square by this is the vertical distance it is going to cover, horizontal distance it is going to cover. So what is its horizontal velocity after t time? So Vx equal to Ux equal to u because Ax is 0. What is the vertical final velocity? Vy is equal to Uy plus Ayt. What is Vy? Sorry, Uy 0. Ay is Qe by m into t. Then what is the deflection? Angle of deflection is nothing but tan theta is equal to, in projectile motion what we wrote? Vy by Vx. What is the Vy here? Qe by m into t by, what is Ux? That is nothing but u. So therefore tan theta is equal to QET by mu. So according to given data, whatever they are going to ask, you can calculate. This is similar to projectile motion in motion in a plane lesson, but in place of A, there we will take minus G or plus G. Here we are going to take QE by M. So horizontal. This is the motion of the charge in uniform electric field. Positive charge moves, it will be coming like this. According to this equation, we can say path of this charge is going to be parabola, isn't it? So I hope you people understood. Thank you.